Hello everyone. Today we are going to solve one problem on riveted connection. So before going to solve this kind of problem, uh, we should read the question properly and come up with the given data first. Okay. So in this problem, we are asked to determine the rivet value of 20 diameter rivet connecting 12 thick plates. So, in this question, until now, we have two data, that is diameter, or you can say as nominal dia. Okay, nominal dia of rivet, which is given by D equal to 20 mm, and connecting 12 thick plate, that is the thickness of the plate T equal to 12 Okay, uh, also we are given that the permissible stress of rivet in shear and bearing are 80 Newton per mm square, and for plate in bearing is 250 Newton per mm square. That is permissible stress in shear, which is given by tau, is equal to 80 kilonewton per mm square, and permissible stress in bearing, which is given by sigma suffix c, is 250 Newton per mm square. Okay, so before going to solve the problem, we need to uh, know the shear condition first. We have to have a clear concept about the shearing failure. Okay, as we are asked to calculate the rivet value for two conditions, that is number A, single shear, and number B, double shear. Okay. Um, in this picture, you can see a bolted connection. Though we are solving one riveted connection problem, but this type of shear failure in both the cases, that means in riveted connection and bolted connection, you can say as same. Okay, so first of all, have a look on the first figure. Okay, in this figure, a bolt is connecting two plates and the load is acting in opposite direction. That means creating shear stress. Okay, and the bolt, or you can say the rivet, okay, suffering like shear stress in single plane, that is connecting plane of this two plate. Okay, so as the bolt is suffering shear stress in a single plane, that's why in this condition we can say as the single shear failure. Okay, but if the bolt is connecting three plates together, that is in the second diagram, you can say connecting plane as two. You can clearly see there is two connecting plane and the bolt is suffering from this shear stress in two plane. That's why we can conclude it as a double shear failure. Okay, is it clear? The single shear failure and the double shear failure. So proceeding to the solution part, we're already in it. So first of all, we need to calculate the gross diameter of the rivet, which is given by small d equal to nominal diameter plus 1.5, and this 1.5 is termed as standard clearance. And to find out the standard clearance, go to table number 19 of IS 800 2007. Okay, there you can have standard clearance for different range of diameter of bolt or rivet. Okay, so we have the gross diameter of the rivet as 21.5 mm, and we can calculate the gross area of rivet with the help of this diameter, that is pi d square by 4, and putting the value of d as 21.5, we can have the gross area as 363.05 mm square. Okay, so one more thing in this portion, we are going to calculate the rivet value. So what is rivet value? Rivet value is always the smaller of shearing strength and bearing strength. Okay, shearing and bearing strength. So in this problem, only the shearing strength will vary for two different conditions, that is single shear and double shear. But bearing stress will be same. So we are going to calculate the bearing strength first. The formula for bearing strength is P suffix B equal to D into T into sigma suffix C. Here D is the diameter, that is the gross diameter of the rivet, T is the thickness of the plate, and sigma C is already given. And putting all the values in this formula, we can have the bearing strength as 64,500 Newton. Okay, uh, this will be common for both the two, that is PB. So coming to the next part, that is calculation of the shearing strength. For the first case, that is number A, uh, calculation for single shear. Okay, so strength of rivet in single shear equal to cross-sectional area of the bolt into tau. Okay, we have already calculated the gross area of the diameter, that is 363.08, and the value of tau is given as 80 Newton per mm square. So multiplying both these two, we can have the single shear value as 29,044 Newton. So comparing these two value, that is this one and this one, we can have the lower as the smallest as 29,044 Newton. Okay, hence the rivet value in single shear equal to smaller of PB and P suffix as 1. And we can clearly see that the smaller value is 29044 Newton. So rivet value will be this one, 29044 Newton. Or you can divide it by 1000 to have it on you know, in kilonewton. Okay, so next we are going to calculate the shear strength in double shear condition. This is nothing but twice the value of whatever we have calculated in the single shear condition. So multiply it by 2, we can have the value as 58,088 Newton. And the same concept will act here also, that is the rivet value in double shear will be smaller of PB and P suffix S2. So in this case, comparison will be done in between 58,088 kilonewton and PB, that is 64,500 Newton. In this case also the shear strength is small, that is 58,088 Newton. So the rivet value will be 58,088 Newton. Or you can say equal to 58.09 kilonewton. Okay, that's it.